Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dopo Jr. I'm your math tutor and I am an instructor of mathematics at the University of Liberia. In today's lesson, we will be looking at implicit differentiation. Now, in previous lesson, we've dealt with explicit differentiation. That is, all of the problems we've been solving have been problems that have been expressed in terms of x. For instance, if you have y equals to 2x plus 1 or y equals to x squared plus 3x plus 2 or f of x is equals to x cubed minus 4x squared plus 2x plus 5. So all of these problems that we've been solving, we notice that on the right hand side of the equation, we only see one variable x, which is the independent variable. And on the left-hand side of the equation, we see the name of the function. So for this one, you have the function y, you have the function y, and you have the function f of x. But what if we have equations of the form x squared plus y squared is equals to 1? The equation of a cycle with the center at its origin. Now, how do we go about solving this problem? We can solve this problem, but this is not being expressed in terms of only x. X is not on one side of the equation, but rather x and y are mixed up within the equation. So one way we could do it by solving for y squared. So we could say y squared equals 1. We send this x squared across, it becomes x squared minus x squared. We want to get rid of this 2. We take the square root on both sides. So it means y is equal to the root of 1 minus x squared. Good. So we can now use extended power rule and solve this problem. So we all agree that we easily solve for y to be able to make this equation to be expressed in terms of only x. That is the independent variable on one side of the equation and the dependent variable on the other side of the equation. Good. What if we have an equation of this form? X raised to the power 100 plus y raised to the power 100 equals x raised to the power 100 times y raised to the power 100, which we will solve later. Can you easily solve for y in this problem? It will be a challenge for you. So based upon that, since we want to avoid, because there will be a lot of other problems that you may see very challenging for you to be able to solve for y, which is the function within the problem. So to avoid solving for y within the different problems that you will receive, we can now employ the method called implicit differentiation. So this equation, they are all equations that we refer to as implicit equations because y is not the subject of the equation. When y is the subject of the equation, we refer to that equation as an explicit equation. This is implicit. So these are the two equations that we need to deal with. We've dealt with this one first in the previous lessons, how to find the derivative of these equations that are in explicit form. We now want to look at the equation in implicit forms. Now take note, when we were finding the derivative of x, let's say y equals to 2x plus 1, we told you derivative notations are y prime dy by dx. That is the derivative of the function y with respect to the variable within the function x. If you are dealing with f, you can say f prime and so forth. Now, if we're finding the derivative of this using the power rule, we can say y prime equals, what's the derivative of 2x? Now the power is 1. Let's review this power rule first before we continue. If you have y equals to ax raised to n, the rule says y prime is equals a, you drop this power, which is n, you rewrite x and subtract 1 from the power, so it's n minus 1. So for example, if we have y equals to 2x raised to the third power, the derivative will be y prime equals, this is 2, we drop this power, 3, and we rewrite x and subtract 1 from this power, which is now 2. So I want you to get that. So 2 times 3 is 6, so it's 6x squared. Y prime is equal to 6x squared. So for this, 1 times 2 is 2, and then you subtract 1 from this power is x to the 0 power. X to the 0 power is just 1. So the derivative of 2 times a variable raised to the first power is just equal to that coefficient. So now this is just equal to 2. The derivative of a constant we told you in the past videos that is equal to 0. So you saw that we have y prime equals to 2. So this is the derivative. Now y is the name of the function. That's the reason why we attach the derivative notation to y. We will also rewrite this as dy by dx. Similarly, when we are dealing with implicit functions, whenever we differentiate the variable y, we must always attach, whenever we differentiate the variable y, which is the name of the function, we must always attach y prime or dy by dx. We must attach a derivative notation to that. So for instance, if we want to find the derivative of x squared plus y squared equals to 1, we differentiate each term. So the first term, the derivative of x squared, we know that is 2x, plus the derivative of y squared, we know that is 2y. But because y is the name of the function, we must attach y prime equals the derivative of 1 gives us 0. So at the final analysis, because y prime is the subject of the equation, we must be able to solve for y prime. So we say 2y, y prime is equals, we send this 2x across. So it becomes minus 2x. We want to solve for y prime, so we divide both sides by 2y, divide this side by 2y. So 2y cancel 2y, y prime now becomes x, negative x over y. So this is how we solve implicit equations. If we were to make this y the subject, x squared plus y squared equals to 1. So we say y squared equals to 1 minus x squared. We take the square root on both sides. We will have y equals to the square root of 1 minus x squared. But we know before we find the derivative, it must be in the form of an exponent. So we can rewrite this radical form in like 1 over 2, right? Because we know that square root means half. Now let's find its derivative using the extended power rule. Because we have a function within, we could also use the chain rule. So let's find the derivative. So we say y prime equals, we drop this power 1 over 2, rewrite 1 minus x squared. We subtract 1 from this power. So 2 times 1, this 2 times 1 is 2. So it's 1 minus 2 all over 2. So 1 minus 2 is just 1 over 2. Times, we differentiate what is inside. So what is inside this is just the derivative of 1 is 0. The derivative of minus x squared is just minus 2x. So this 2 can cancel this 2. Y prime now will be, let's write our division line like this. We have this x in the numerator, and because this power is negative, it goes down within the denominator. So it's 1 minus x squared raised to the power 1 over 2. Right? So you see, x over y. But we solve for y right here. Right here, we solve for y right here. What did we receive? We received 1 minus x squared, all raised to the power half. So you could say y prime is equal to minus x all over 1 minus x squared raised to the power 1 over 2. But in some cases, you may not be able to solve for this y so easily. So based upon that, you just leave it as it is. It's not really a problem. You just leave it as it is. Your major focus should be how to solve for y prime. So this is how we find the derivative of implicit equations or implicit functions. So now let's look at additional problems. Question number 2, x raised to the power 1 over 2 plus y raised to the power 1 over 2 or equals a raised to the power 1 over 2, for example. So we continue. Find its derivative. We use the power rule. We drop this power 1 over 2. We rewrite x 1 over 2. We subtract 1 from this 1 over 2. Plus, we drop this power again 1 over 2. Y raised to the power 1 over 2 minus 1 equals. Now, a raised to the power 1 over 2. This a is a constant. It's a constant. So it's just equals to 0. Now we can subtract 1 over 2, x raised to the power half minus 1. So whenever we take half from in 1, we left with half. But because we are taking 1 from within half, it will be negative 1 over 2. Or you just say 2 times 1 is 2. So it's 1 minus 2 all over 2. So 1 minus 2 is just 1, minus 1. Plus 1 over 2 y raised to the power minus 1 over 2. But now, we told you because this y is the name of the function, always when you differentiate this y, attach y prime or dy by dx to indicate that you have differentiated the function so that you can be able to solve for y prime after you have further simplified the problem. So this is now y prime equals to 0. Now what we need to do is to solve for y prime. We send this term across, or we say let's multiply this whole thing by 2 to get rid of this 2. So this becomes minus 1 over 2 plus y minus 1 over 2 y prime or equals to 0. Because 2 times this is cancelled and everything. So we send this term across, it becomes y raised to the power 1 over 2 y prime equals negative x minus 1 over 2. So we divide both sides by y raised to the power minus 1 over 2, y raised to the power minus 1 over 2. So this cancels this. So y prime now becomes minus x to the power minus 1 over 2 all over y to the power minus 1 over 2. But because this power is negative, this power is negative, we can reciprocate. Whenever a power is negative, you can reciprocate and that negative will change to positive. So y prime can just be minus y raised to the power half all over x raised to the power half. Right? So someone can say, I don't want to have because this half means square root. I don't want to have a square root within the denominator. I want to get rid of the square root within the denominator. Yes, you can do that. But don't bother yourself to do that in all of the problems because some of the problems might be complex. So we can rationalize this x, and then you will have the square root of y times the square root of x. You just have the square root of xy. divided by the square root of x times the square root of x. The square root will cancel because it's like saying half plus half is just 1. So it's just equal to x. So yes, this can be our answer for the first problem, or we say the second problem now. Let's solve more problems. Okay, so I brought a problem initially. What if we had x raised to the power? Let's solve a simplified one, like x to the fourth power plus x y to the fourth power, or equals to x to the fourth y to the fourth. So we're going to solve this problem, and we're going to further simplify this problem in a way that you can simplify similar problems in the future. And I'll put some related problems so that you can practice on your own. So again, we carry on our regular implicit differentiation. We differentiate x to the fourth power. It gives us 4x. Remember, you drop the power and reduce the power by 1. It's 3 plus, you drop this power, 4y to the third power. We subtract 1 from this, it's 3. We attach y prime because y is the name of the function. All equals. Now, in this case, we have two functions. We have the independent variable and the dependent variable being multiplied by each other. So the rule we can use here, because since we have this times this, we can use the product rule. So we know that the product rule says whenever we have a function g of x times h of x, for example, two functions, or you have y equals to u times v, so y prime will be u v prime plus v u prime. That is, you hold this u function constant and you differentiate this v function, you get v prime. Plus, you hold the v function now and you differentiate u, you get u prime. That's it. So that's the same thing we're doing right here. So we hold on to x to the fourth power and differentiate y to the fourth. So we get 4y to the third y prime. Don't forget. Plus, we hold this y to the fourth and we differentiate x to the second, or x to the fourth. We get 4x to the third. Now, let's simplify. All of the terms with y prime, we must make sure we put them one side of the equation. So we have 4y to the third y prime minus x. So it's just 4x squared y to the third y prime equals 4x cubed y to the fourth. This one goes across, it becomes minus 4x. So we can factor out y prime. So it gives us 4y cubed minus 4x squared y cubed, and then y prime outside. We just took this y prime from there. And then this side, we can bring this x outside. This x, we can bring this x. That's it, this 4x, we can just factor out 4x. So we're left with x to the third, y to the fourth, minus 1. Divided by what is left. Down here now, we can divide both sides by 4y cubed minus 4x squared y cubed, 4y cubed minus 4x squared y cubed. So this carry this out, you have y prime. Now we can also factor out this 4y, we can factor out 4y in both of them. Let's see. This is cube, cube. Okay, so we can factor out 4y in the both of them. 4y cube. So when 4y cube comes outside, it will just be 4y cube. And then this will be 1 minus, this is x squared. So this one will go out, right? So this 4 can cancel this 4. What will we be left with? We'll be left with x cubed y to the 4th power minus 1 all over y cubed minus x squared. Oh God. Okay. So we continue. You have to be, we have to be very careful before we miss some signs in this problem, because we don't want to miss any sign. So let's try to run over it quickly. We have 4, we add x to the 4th power, so it's 4x cubed plus 4y cubed, y prime. And then this one, we hold x to the 4th, and we differentiated this 4y cubed, y prime. And then this also, we held this y to the 4th constant, and we differentiated this, we got 4x cubed. So this term and this term, we send them on this side of the equation. So it's 4x to the 4th power. What is it? This 4x to the 4th power. We don't have it here. This 4y to the 3rd power y prime. So it's 4x to the 4th. Okay, so this is 4x to the 4th power. You see, we made some signs here. And then this y to the 3rd. Okay, that's exactly what we missed. So on this side, we have 4x cubed y to the 4th. And what we have 4x cubed. We send it across. This is 4x cubed across. Great. Now, this is 4y cubed, y prime. So y prime is being factored out. This is just 4th power, and this is also 4th power. So we have to be very careful so that we cannot make mistake. So this area we have cube and cube, 4x cubed and 4x cubed is out. So what is left here is just y to the 4th power. And then this is just 1. Then what is left down here, after we factor out this one, so we divided both sides by this expression. So this is now to the 4th power. Now we can factor out 4y cubed. So we'll be left with 1 minus x to the 4th power. Excellent. So this 4 can cancel this 4. We'll be left with x to the 3rd, x to the y to the 3rd, and then this is now y to the 4th minus 1 divided by 1 minus x to the 4th. Now, at this point, in some books, you will notice that some books will stop at this point. Some books will tell you that this is the final answer. But there's a book called A.W. Goodman that always reduces the problem to its lowest. And sometimes for me, I go beyond his reduction, 1 or 2 steps or a few steps beyond that, because I love to reduce the problem in some simplest forms. So let's further simplify this problem. We saw that the problem that was given to us was x to the 4th, y to the 4th, x to the 3rd, that's x to the 4th, y to the 4th. This was a problem, right? Now, we can solve for this x cubed and y cubed. So to solve for x cubed, we just rewrite this expression. So it's x to the 4th plus y to the 4th equals, to find x cubed, we can say x times x cubed, y to the 4th. So we can divide this out by x, y to the 4th, x, y to the 4th. So x cubed would just be equal to x to the fourth plus y to the fourth divided by x y to the fourth. So this is x cubed. We can also solve for y cubed in a similar form. So it's x to the fourth plus y to the fourth equals x to the fourth times y to the third. So we divide this out by x to the fourth y and x to the fourth y. So y prime would just be, y to the third would just be equal to x to the fourth plus y to the fourth all over x to the fourth y. Now we replace wheresoever we see x to the third, we're going to replace it with what we've gotten. So let's put this problem right on this side. So it's y prime equals to x cubed y to the fourth minus 1 all over y to the third times 1 minus x to the fourth. So we have y prime x to the third. X to the third is this expression. So it's x to the fourth power plus y to the fourth all over x y to the fourth times y to the fourth minus 1. All divided by, down there we have y cubed. So this is y cubed, x to the fourth plus y to the fourth all over x to the fourth y times 1 minus x to the fourth. So this can now be equal to x to the fourth plus y to the fourth times, or let's just multiply the both of them so that we can waste time. So we say x to the fourth times y to the fourth is x to the fourth y to the fourth, x to the fourth times minus 1, x to the fourth times, let's say x to the fourth, right? And then this time this gives us y to the eighth power, and then y to the fourth times minus 1 is minus y to the fourth. So we have multiplied this by this, all divided by x y to the fourth. Now this is the division line, so we can say divide, and then we'll do this multiplication as well. X to the fourth times 1 is x to the fourth. X to the fourth times x to the fourth is x to the eighth power. Y to the fourth times 1 is positive y to the fourth. And y to the fourth times minus x to the fourth is minus x to the fourth, y to the fourth. Divided by x to the fourth y. So we say when you have a problem and you have a division problem, you can rewrite the first fraction. This is the first fraction. Change this sign to multiplication and reciprocate this fraction. So what do we have there? So it's y prime equals x to the fourth y to the fourth minus x to the fourth plus y to the eighth minus y to the fourth divided by x y to the fourth times. So we have x to the fourth y all over x to the fourth, x to the eighth plus y to the fourth minus x to the fourth y to the fourth. We divide them. Okay, so we're almost done with this problem. So this expression, this y to the first can cancel 1 from here. You just have y to the third. This one can cancel 1 from here. You have x to the third. Now, note x to the fourth, y to the fourth, x to the fourth, y to the fourth is just equal to x to the fourth plus y to the fourth. So y prime equals, this term is just x to the fourth plus y to the fourth minus x to the fourth plus y to the eighth minus y to the fourth divided by y to the third is what we got here, y to the third times, we do the same thing down here. Up here is x to the third. This expression, so it's x to the fourth minus x to the eighth power plus y to the fourth minus. So this minus will affect everything inside, right? So x to the fourth, y to the fourth is just equal to this. So both of them will be negative, and then minus y to the fourth. So what do you observe? We observe that x to the fourth cancel x to the fourth, y to the fourth cancel y to the fourth, x to the fourth cancel x to the fourth, y to the fourth cancel y to the fourth. What is left? You have y prime equals, in this term you just have y to the eighth power all over y to the third times x to the third over minus x to the eighth power. What is next? This y can cancel, this y to the third can cancel, so you have y to the fifth, and then this one can cancel 3 from here. You have x to the fifth. But there is one thing that we left out. So this is now equal to y to the fifth all over x to the fifth. Okay, we did not leave anything out. So this is the simplified version of this problem. So if you were given, let me show you similar problems. If you are giving x to the second power plus y to the second power equals x to the second, y to the second, the answer for this would just be y prime equals to negative. The same way this thing is, this form appears. Y to, now you saw that the power was x to the fourth and it increased by 1. So this will increase by 1 all over x to the third. If you are given x to the 100 power plus y to the 100 power or equal to x to the 100 power, y to the 100 power, like we showed you in the example previously, your answer here will be y prime is equal to negative y to the power 101 all over x to the power 101. Likewise, if it was the fifth power, it's going to be the same pattern. The 10th power, the 6th power, the 8th power, they're all going to be the same pattern. Okay, so let's solve another problem. When we solve more problems, you tend to understand the topic more than for us to just solve 1 or 2 problems and be done with it. So we want to solve this problem. Okay, so question number, is it 4, right? Question 4. We have y squared. Let's solve some. Let's solve this one. X squared plus y squared. What is it? 2x minus 2y. Okay. 2x squared minus 2y squared, and then raised to the second power as well. So let's solve this problem. In similar form, we observe here that x and y are mixed up within this equation. So the equation is not an equation that y is the subject of the equation. So based upon that, we apply implicit differentiation. Had it been the case where y is the subject of the equation, then we would have applied explicit differentiation. So for this case, we know that whenever you have an expression where something within is raised to a power, we can apply the extended power rule. That is, we drop this power, which is 2. We rewrite the expression in x squared plus y squared. And we subtract 1 from this power, right? So you subtract 1 from 2, it gives you 1. Then you differentiate inside. So the derivative of x squared is just 2x. And the derivative of y squared is also 2y. But because y is the name of the function, we must attach y prime to y. So we've done with this. Equals the derivative of 2x squared, 2 times 2 is 4, so it's 4x. And the derivative of 2y squared, 2 times 2 is also 4, is 4y. Then we attach y prime as well. So we need to ensure that all of the expressions with y prime be one side of the equation. But we cannot just take this expression from within this unless we multiply the first binomial by the second binomial. So we say x squared times 2x times this 2 gives us 4x to the third power. X squared times 2y, y prime, gives us 4x squared, y prime. Y squared times 2x gives us 4x, y squared. And y squared times 2y, y prime gives us 4y cubed. And then y prime. On this side of the equation is 4x minus 4y, y prime. So all of the terms now with y prime, this term and this term, we must put them on one side of the equation. So we maintain this. So it's 1, 2, and 3. So there's 4x squared y, 4x squared y. This one is plus 4y cubed. And then this one, if you send it across, it becomes positive. So it's positive 4y. Now I took the y prime from in every term, so it becomes y prime. All equals to 4x. Then we send this one across now. Minus 4x cubed. We also send this term across. Minus 4x y squared. So if we divide this out by this expression and divide this out also by this expression, we will get y prime equals, now this 4 is in every term, so we can factor out 4. So 4 comes outside, it's x minus 4x cubed minus, oh sorry, the 4 is already outside, minus x y squared. But we can also factor out x. So here will just be 1 minus x raised to the second power, and this is just y squared divided by what we have down here, because this was divided on both sides. So this, the 4 is outside, y, and y in 3 terms, so y is also outside. So what do? We are left with x squared plus, this is y squared plus, this is just 1. So this 4 and this 4 cancel. You have y prime to be equal to x times 1 minus x squared minus y squared all over y times x squared plus y squared plus 1. We have anything similar from the beginning that we can replace? Not really. Not really, really. Let's see. If we replace, okay, this has a power of 2. So we just maintain this as our final answer. So thanks ever so much for watching. Please subscribe. See you in our next lecture where we will solve more problems involving implicit differentiation. Thank you.